Okay, so let's do another polynomial division problem. This time with another little twist that we might encounter because we want to get all of these out of the way so we know how to handle everything. But of course, if we understand the process, right, instead of just memorizing an algorithm, this is generally true, right? If we understand the process instead of memorizing an algorithm, then we can handle the twists and turns and the curveballs and stuff like this. If we memorize an algorithm that we don't understand, we are always in danger of either making mistakes that we don't know are mistakes, getting wrong answers that we don't know are wrong, or just kind of getting lost in the middle of it and being unable to continue, or sort of not being able to handle the weird ones, right? When they give you something that you haven't seen before, if they change something, and they love to do that on university tests, of course, they love to keep you on your toes like that, we won't be able to handle it. So we're going to use our understanding of the process and why it works to handle a little bit of a twist in this one. So again, we set up our division statement, right? The dividend 4x4 minus 3x cubed plus x squared minus x plus 1 is equal to 4x minus 3 times this quotient, which we're going to figure out. We're going to reverse engineer it, and then plus the remainder, which will be a constant because the divisor is a linear term. And the remainder, of course, always has to be a lower degree than the divisor. So what is the first thing we try to match, right? It's always the highest term and then worry about the rest of it after. So this is a 4x to the 4, and we have a 4x to multiply by. So the first term of our quotient has to be an x cubed, right? We have no choice about this. We need an x cubed to multiply by the 4x to get 4x to the 4. And that's great. We have matched that term. We have our 4x4, 4x4. Then what do? We distribute it in, and we multiply by the negative 3, and we get negative 3x cubed, right? X cubed times negative 3 is negative 3x cubed. And how many do we want? This is a little bit different. Now it's exactly the same, right? We, on the first shot, we got the right number of x4s and also the right number of x3s. And we haven't seen this before, right? What do we do here? This is where if we're memorizing algorithms, we're probably going to get a little bit stuck. But what was the idea behind this? The idea was that we match the highest power of x, and then we see how many of these come out, right? How many of the x cubeds come out, and then we match them by putting in the next term. So we're used to this not being equal, and we'd have to add, like, maybe this was, 5x cubed, and we'd have to add 8x cubed here, and then we would put plus 2x squared or something like that. When it's the same, it's a little bit different, but the process is the same. We say, okay, great, we match these first two. So now our attention turns to the next one that isn't matched, right? Which is x squared. So we're going to match the x squared and then go from there. This is going to be a little bit to do some fractions stuff, right? We're going to have to get fractions involved here because I think what do I have to multiply 4x by in order to get x squared? Well, it's going to have to be and so let me put the next thing here. This is the x squared. So the next thing we have to put is a plus 1 over 4x, right? We need positive 1 over 4x to multiply by the 4x and get us this x squared, right? The x's will make an x squared, and the 4 and the 1 over 4 will cancel, and we will get plus x squared down here. And I'm just putting it sort of separate from these so we can see that this is the next kind of phase of what we're doing here. So we distribute that in, and it gives us the x squared, but it also then multiplies by the negative 3, and we get negative 3 over 4x. And we get negative 3 over 4x. How many x's do we want? We want negative x. So what do we need? What do you have to add to negative 3 over 4 to get negative 1? Well, it's negative 1 over 4. Right? Negative 4 over 4 is negative 1. So we need negative 1 over 4x. So we have to put in, as the constant here, we have to put in negative, but we're going to multiply it by a 4x. So this is going to have to be negative 1 over 16. So we're going to put in negative 1 over 16, right? Negative 1 over 16 will multiply by the 4x and give us negative 1 over 4x. Right? The negative 16 in the denominator will cancel with the 4 in the numerator, become a negative 1 over 4, and then we have an x. Then we take the negative 1 over 16, multiply it by the 3, and we get positive 3 over 16. And so this is not, of course, the constant we're looking for. We're trying to get a constant of 1. So what do? We have to use the remainder to take care of that, right? And what do we have to add to 3 over 16 to get 1? Well, 1 is 16 over 16. So we're going to add 13 over 16. 13 over 16 plus 3 over 16 will be 16 over 16, which is equal to 1. And so we dealt with kind of two twists here, right? One of them was that we didn't have to correct for the x cubed term there. The other one was that we have to use fractions. So if you need a little bit of work, usually people are sort of thrown off by the fractions thing. People don't like adding fractions, including me, right? Nobody wants to have to do this. But I can tell you, as someone who used to think, oh, how can I do this? Every time a fractions one came up, just practicing it by hand. It makes it a lot easier. So we wind up with 4x4 minus 3x cubed plus x squared minus x plus 1 is equal to 4x minus 3 times our quotient, which is x cubed plus 1 over 4x minus 1 over 16. And notice we don't have that x squared term because we didn't need to put in an x squared term to match the x cubed, right? We can understand that because we understand our process. And then, yeah, the remainder is 13 over 16. And I will see you in the next video where we're going to deal with another potential hiccup, another little twist that we can run into in these things that we will not get thrown off by because we understand the process.